Gas laws. Gas, when we talk about, it is one among the states of matter. We have three states of matter, that is solid, liquid and gases. But gases are the only state of matter that can be compressed very tightly or it can be expanded to fill a very large space. Gas laws are the law that will relate the pressure, volume and temperature of a gas. Or to simplify, we could say that gas law will deal about how gases will behave with respect to pressure, volume, temperature and the amount. So the first gas law is the Boyle's law. Boyle's law was named after Robert Boyle, or it was named for Robert Boyle. And Boyle's law is also known as pressure volume law. So the name itself says pressure volume law. That means it will give you a relation between pressure and volume. So when it gives a relation between pressure and volume, that means the temperature and mass should be constant. So we could conclude saying that the Boyle's law states that the volume of the given amount of gas at constant temperature will vary or it will be inversely proportional to the pressure when the temperature and mass are constant. Or in simple, we could say that the best way to describe is the product of your volume and pressure will be equal to a constant value. So this is about your Boyle's law. The next law is Charles' law. Charles' law is also known as temperature volume law, and this was named for J.A.C. Charles. J.A.C. Charles. So this law gives you a relation about the temperature and volume. So the name itself says temperature volume law. So it gives you a relation between temperature and volume. That means the pressure should be constant. So we could say at constant pressure, the volume of a given mass of a gas will be directly proportional to its absolute temperature. Or in simple, we could also say that V by T will be equal to a constant value. So suppose if we assume V1 to be the volume of a gas at a temperature T1 and pressure is remaining constant. So when we say volume is directly proportional to temperature, that means if the temperature of the gas is being increased, the volume will also increase. So for example, if we say if the temperature of the gas we are increasing it to T2, the volume will also increase to V2. So according to this law, we could say that it is V1 by T1 will be equal to V2 by T2. So Charles' law says a direct proportional relationship between your temperature and volume, keeping pressure to be constant. The third law is your Gay-Lussac's law. This was named after Joseph Gay-Lussac, which is also known as pressure temperature law. That means, as usual, the name says that it will give you a relation between pressure and temperature, keeping the volume to be constant. So according to Gay-Lussac's law, the pressure of a given amount of gas at constant volume is directly proportional to the temperature. So in simple, we can say pressure is directly proportional to temperature, or we could simplify saying pressure divided by temperature will be equal to a constant value. And the most important law is Avogadro's law. This is also known as the volume amount law. That means it will give you a relation between the volume and the amount of substance. So Avogadro's law gives us a relation between volume and the amount of substance when we are maintaining a pressure and temperature of constant. When pressure and temperature are held constant, your volume will be directly proportional to the amount of substance, or we could say volume divided by amount of substance will be equal to a constant value. And after analyzing the four laws, once we combine these four laws, we will get our equation that is called as your ideal gas equation. So this is also called as your combined gas equation of the three law. So according to your Boyle's law, we got that volume is directly proportional to 1 by P. And according to Charles' law, we said volume is directly proportional to temperature. According to Avogadro's law, volume is directly proportional to the amount of substance. So once we combine, it will become as volume is directly proportional to NT by P, or we could say V is equal to, let us remove the proportionality constant by taking proportionality symbol by taking a constant, that is your R. So we could say PV is equal to nRT, which we consider it to be the ideal gas equation. Hence, the gas laws are very important, or they are the main source from which we derive the ideal gas equation, that is PV is equal to nRT. So this we use for many numericals to solve, that is our ideal gas equation.